Hi everybody. Don't worry, it's still Monday. Elliot does change his clothes. We are doing another lesson. Being Thanksgiving week, I'm doing 2 lessons on Monday. Now, this lesson is actually meant to be watched on Tuesday and pertains to the classwork that we're going to be doing on Wednesday, the Wednesday before Thanksgiving. Um, We're going to be solving exponential and logarithmic equations, this time with a calculator. So I look at number 1 here. I see 3 to the x equals 81. I know this one. It's x equals 4. You're not going to see a problem like this on today's lesson. Well, you just did. But because you can just solve this one by hand without using a calculator, that's actually, we've learned how to solve these type of equations already. What if it says something like this, that you get 3 to the x equals 50? What do you do? Great question. I'm going to present 2 different techniques, and you can use whichever technique you want. I think the easiest thing to do is to change this into a log first. And if I change this to a log, it becomes b to the y equals x. It becomes log base 3 of 50 equals x. b to the y equals x. And log base 3 of 50. This is my exact answer, just simply changing it into log form. I'm done. But if you want a calculator approximation, you then change this to log base 50, not log base 50, just log of 50, log base 10 of 50, divided by log base 10 of 3. So I have log 50 divided by log 3. And then you can just pull out your trusty calculator. And my calculator tells me, clear that out, that log 50, close that, divided by log of 3, close that parentheses, gives me an answer of 3, or approximately 3.561. So there's my approximate answer. That's technique 1. Technique 2. 3 to the x equals 50. I don't remember my technique 2. I have in my notes that I have 2 techniques, but I'm having a hard time off the top of my head remembering what the secondary technique is, because this first technique is so easy. I don't think I'm going to present another technique. I guess just you do log of both sides? I guess, okay, yeah, that's the second technique, where we have these 2 sides, they say that they're equal, so we could always take log of both sides. And when you take log of both sides, it can be any base you want, so I'm just going to have it be log base 10. So I have log of 3 to the x equals log of 50. And then I could use that exponent rule, that this exponent on this x has to go out front. So x times log of 3 equals log of 50. And then to get x by itself, I could just simply divide both sides by log 3. And I get x equals log 50 divided by log 3. And because this has been my work, this would actually be my exact answer. And then my decimal approximation would be x is approximately, I notice here that it's the exact same thing that I had written up here. So it would be 3.561 is my approximation. So once again, I took log of both sides. I then used the exponent rule and brought the x out front, divided both sides by this log of 3. That gave me my exact answer. Popped this into the calculator. That gave me my decimal approximation. The other technique, which I don't know, they both kind of, I think this one's easier on my brain to think about, but this one's just plumb easy. You just change it from exponential form to log form, and then that is your exact answer. You move into change of base, that gets you your decimal approximation. That's a good demonstration of why you need to show your work, because if you use this technique, your exact answer will look this way. Whereas if you use this technique, your exact answer will look that way. I don't care which technique you use, it's your choice. I have 3 more quick examples here to practice these out on. Example 3, 6 to the x equals 15. Example 4, 7 to the x equals 93. And for these 2 examples, I'm going to use the 2 different techniques. So if you're working these with me, pause the video, try them out on your own, and see how it went. This one, change it into a log form. When you've changed it to a log form, it becomes log base 6, same base, of 15 is equal to x. That's my exact answer. But then as I work to my approximate, it becomes log 15 divided by log 6. And I type that into my calculator. Log 15 close divided by log 6 close. Got an answer of 1.511. And that is my approximate answer. All right, and then on the second one, so I'm going to use the other technique for this problem. So for this one, if I took log of both sides, it'd be log of 7 to the x equals log of 93. I then use the exponent rule and I bring the x out front. So x times log 7 equals log 93. To get x by itself, I divide both sides by log 7, and I get log 93 divided by log 7. This is my exact answer. I can then just type this into my calculator to get my decimal approximation. Log of 93 close divided by log of 7 close, and I got an answer of 2.329. All right, and that's my approximation. Actually, I have a lot of examples, but they go kind of quickly. Number 7, or this is example number 5, excuse me. What if I had 2 times 7 to the x plus 3 equals 200? So this is a little bit more complicated. Nothing fancy though, but you don't want to go into log form or taking log of both sides until you've dealt with this 2. So I'm going to divide both sides by this 2. So I get 7 to the x plus 3 equals 100. And then, depending on which technique you use, I think I'm going to change this to log. If I change this to log right now, it becomes log base 7 of 100 equals the exponent x plus 3. X is almost by itself. So I then subtract 3 from both sides, and I get log base 7 of 100 minus 3. And this is my exact answer. And then as I work to my decimal approximation, this would become log 100 divided by log of 7 minus 3. And then for my decimal approximation, log 100 divided by log of 7. Then I'm going to hit enter to get that decimal, which is 2 point something, and then just subtract 3 from it, and I got negative 0.633 is my approximate answer. Okay, so that is dealing with exponents. Now what about the other one? We also needed to solve some logarithmic equations, and I just have 2 examples of solving logarithmic equations. So this is example 6. Example 6, I have 5 times log base 2 of x equals 30. Can't do anything with this until you've divided both sides by 5 so that the log is isolated by itself. And if I do that, I get log base 2 of x equals 6. This is not even a calculator problem. At this point, you just go into exponential form. 2 to the 6 equals x. And everybody knows that 2 to the 6th is 64. And I always know that because when there's 64 teams in the NCAA basketball tournament, you got to win 6 games if you want to win a championship. Use sports. People like sports. Last one, number 7. Log base 5 of 7 plus log base 5 of x equals 14. All right, we have to use the condensed formula. You don't want to do anything with a double log. You can only work the magic if you condense. So condense this into a single log, so it becomes log base 5 of 7x equals 14. Now we can go to the exponential form. 5 to the 14 equals 7x. B to the y equals x. B to the y equals x. And then divide both sides by 7. So you get 5 to the 14 divided by 7. And this is an exact answer. I got a feeling my calculator is not going to want to do 5 to the 14. Oh, it did. 5 to the 14 gave me this big old number. And if I divide that by 7, there's no way it's going to divide evenly, will it? No, it did not divide evenly. So then to keep the exactness, I'm just going to go back to my 5 to the 14. I got this giant number. It has 6, 1, 0, 3, 5, 1, 5, 6, 2, 5, comma, 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 so that's what, 6,103,515,625 all over 7, and that is a nice exact answer. All right, so that is solving equations, solving exponential and logarithmic equations for x. Even though I'm posting this video on Tuesday, it's meant to actually be watched on, or I'm posting it on Monday, but you could either watch it on Monday or on Tuesday. This is going to help us with our classwork on Wednesday, and this is this type of stuff that you see in this is, I guess if we want to talk objectives for a minute, these are solving exponential equations. Well, that's 2f and 2g. So 2f was solving exponential equations using logarithms. Going the wrong way. So that was like the first half of this lesson. And then 2g, I can solve logarithmic equation. It says equation, but it's meant to be equations. But anyway, that was the second half of this lesson. So that's objectives 2e and 2f, both things that we're going to be quizzed on next. Oh, 2f and 2g. Those are both objectives we're going to be quizzed on next Tuesday. So have yourselves a great day, and I'll talk to you later. Bye-bye.